So Python F strings are cool, but they're kind of old news. Well, basically Python F strings allow you to insert the result of pretty much any Python expression into a string. Let's take a look. Let's say we have a name, Lucas Viana, and you want to say hello to that name. So how do you do that? Well, with F strings, it's simple. Before the first opening quote, add an F, and then anything inside curly braces gets evaluated and inserted into that string. So all we have to do is type name here, and then when we evaluate that, we print successfully hello Lucas Viana, or whatever the variable name was. But as I said, this is old news, and this truly is just the basics. It is only when we look into the details that things start getting more interesting. So here's tip number 1. Know where to find the documentation. So the Python documentation is wide and deep, and rightfully so. The language has many features and a comprehensive standard library, so it can get a little bit daunting to try to find a specific chapter. So let's browse to docs.python.org. We're looking for F strings, and that is baked into the language. So let's go to language reference. And then we look under literals, chapter 2.4.3, formatted string literals. Take your time to understand this. The syntax may look a little bit dense at first, but it's not that hard. And then when we read through this and try to digest and try to understand what the format spec, we realize that this page doesn't really tell you exactly what a format spec is, but it links us to the Python format specifier mini language. And here we find another one of the syntax definitions, so you can understand that there is really no way around learning these things. Well, I have carefully read all of those specifications, and that leads us to tip number 2. Different data types have different options. This is basically a condensed aggregation of many of the things from the documentation that we just looked at. And then I realized that of all of these options, we will never use all of them at once. If my expression is a string, I only have these options available. If my expression is an integer, on the other hand, I only have these options available. And if it's a float, I only have these options available. Don't worry about all of that for now. The coming tips will go over the best combinations for those options. Some of these options, though, can be used for any data types. And my favorite option of all leads us to tip number 3. Abuse the debugging help. If you have an equal sign right after the expression, Python will not only insert the result of it as usual, it will also insert the expression itself inside the string, so you don't have to do it manually. How great is that? So let's go back to our greeting example here. Let's add an equal sign after the name. Now we see the result is printed, and before it we see the expression followed by an equal sign. And the expression gets printed out unmodified really for any expression. Let's take a look. So if you add something after here, so as we saw before, if we convert this to uppercase, the entire expression gets printed out. Tiny equal sign at the end, and boom, you get awesome results. So the next tip is more like a full program. I went all in. So creating tables with F strings is a breeze. Let's take a look. So this is done using these 4 fields: fill, alignment, width, and possibly a maximum width when we are dealing with strings specifically. So back to our trusty notebook here. Let's say that we have a list of items for sale. Each item has a name, say jeans, and a price, $100 or whatever. Bomber jacket. And let's change the price to $100. Last item, let's say shoes, whatever, and costs $8. Let's start by simply printing them out. Nothing fancy. So for item in items, print. Let's already start with our F strings, and let's insert a replacement field. An item name and item price. And this one also needs to be surrounded by curly braces. Perfect. Print this out, we see that it's nothing fantastic. Now let's pimp this up. To improve this, let's use the width format specifier. We simply add a colon and a number for the width on both fields here. Colon and number. And now we see the things align much better. But I'm feeling they are a little bit too far apart, so let's reduce this to 15 and see where we end. And now let's copy this line and paste it over here at the top, and we're creating a header here. So we're gonna say that this is the name and this is the price. Things are starting to look much better. Now let's play with the alignment option. For the alignment, we have three options. A left square bracket to align left. Numbers align right by default. We can align right, so let's try here with the right square bracket. The names jumped to the right, or we can align center with the caret. Now the names are aligned center. Let's keep this aligned left for now. I don't use this often, but you may specify any fill character by adding the character to the left of the alignment option. So let's insert the $sign here and see that it looks terrible. So to the left of the alignment, everything up to the width gets filled up with these $signs. Yeah, it looks terrible, so let's remove it. But there it is. Like, for all that I know, this is a table, and all that we had to do was to add a couple of characters after our expressions. And this starts to demonstrate the power of these things, and they go much further beyond. Let's say, for example, that you have a pretty long name here. Bomber jacket is a very long name, okay? Well, now you see that our alignment was lost. So what do? That leads us to our next tip. Use the max width field for strings. The maximum width option is quite hidden in the documentation, and it comes almost as an afterthought in the text. The field is actually called precision in the documentation and is commonly used for floating point numbers. So here's how we fix this overflow problem that we're having. We use the max width to truncate the name by adding a dot followed by a number that specifies the maximum width of this field. And voila, we see here that the bomber jacket is a long name, gets truncated to the maximum of 15 characters. Most of the times when tabulating values, it is a good idea to use this maximum width for strings. So the next tip takes things to the next level. We can parametrize the formatting options. Let's take a look. So just to give an example here, let's say that we want to parametrize the width. So the width is variable. So everything with C15 we will replace by the variable that we're going to create called width. That's equals to 15, but let's create it as a string already, so Python doesn't need to do any extra work. And then in here, inside our replacement field, we have another replacement field with the width inside. And everywhere we see this, we're gonna go around and replace. And I'll even go ahead and say that we're always gonna want the maximum width to be the same as the width. So now we're free to change this width to whatever we want, say 50. And everything follows along quite nicely. And if we want to parametrize also the alignment, we would be able to do that just as easily. We just need to create a variable called alignment and say that this is the alignment that we want. And if we want to change the alignment to center, for example, that's all that we need to do. But for now, we're gonna keep things unparameterized. So let's undo this all. This example only uses positive numbers, but if we had negative numbers, the numbers wouldn't quite align because the sign would be in the way. So that leads us to tip number 7, align numbers correctly, taking into consideration their signs. So let's take a look. So let's say that some of these numbers are negative, and for clarity, let's start with integers. So we're gonna have to change the price by something that is an integer quantity here. So let's say quantity. So everywhere we see price, we change to quantity. And then this quantity is 17, this one is say 20, and this one let's use a negative quantity. Well, I don't know what a negative quantity really means. Maybe you oversold a product, or maybe you have some pre-orders or whatever that means. Let's look how it prints out. And by the way, we also need to change this one to quantity. Let's see. And also let's get rid of this long name here so we have a nice separation of the field. So now we see that the things don't look terrible, but they don't look perfect. So here, since we're dealing with integers, we have these options for formatting integers. We can see that by preceding the width field with a plus character, we tell Python to show the plus sign even for positive numbers. So let's try this out. If we have the plus sign before the width, we're telling Python to print the plus sign even for positive numbers. And if you ask me, this aligns already a little bit better. But there is an even better option, that is to replace this plus sign by a blank space. So Python allocates this little space for the positive numbers, just so the positive numbers align with the negative numbers. That's neat. What is not really neat though is that this space here, having a white space really means something in Python, is not very Pythonic. So that's the kind of stuff that makes me shed a tear. So I would have this ugly white space with a mini in the middle of my stuff. Tip number 7, right align and pad with zeros. There might be a situation where you want to align your numbers to the right and then pad them with zeros to the left. And that is not always very obvious, and I'm going to show you why. There are two ways really for filling up numbers with zeros up to the width, and one of them is wrong. So let's try out some dumb ideas here. Let's start by showing the plus sign for all the numbers so things become very clear. So the fill character really comes before the alignment character. Here we can already see that this was a terrible idea. We certainly don't have 17 billion trillion items for sale. So padding numbers with zeros to the right is always a terrible idea. So let's do the better thing, not correct yet, and align it to the left. Zeros here don't mean anything, but then we got this plus sign trapped in between. So how do we fix that? This little problem here is the reason why we have this zero option here, which means pad with zeros, but be smart about the signs. So instead of doing this, let's precede the width field by a 0. So we have this different option. So Python knows that we want mathematical correctness. And it still looks strange. So what's going on? The solution comes to our next tip. Use the equal alignment option for numbers exclusively. The equal alignment operator is the default for numbers, and unless you want that left alignment aesthetics, the equal alignment operator will always do the right thing for you. So let's check it out. So all that we have to do is to replace this alignment, the right angle bracket, by the equal sign, which also means align right, and voila! Now Python knows that we want mathematical correctness when it comes to padding our numbers with zeros. So we know that all these zeros to the left don't mean anything, and the plus sign is not trapped inside there anymore. And this, ladies and gentlemen, is how you align right and pad with zeros. I have no idea why you would want to do that. I have never needed that, but in case you need, there you have it. And our next tip, I promise, is going to be a lot more useful. I use this all the time, and it's going to help you be kind to your customers around the world. Use locale specific formatting. Let's check it out. To exemplify this, I'm going to need some larger quantities into the thousands. So let's take these and add 3 zeros to each one. And let's also remove this right alignment nonsense. And the right alignment, since it's the default, we're gonna keep it like that. We're gonna remove the plus sign. That is terrible syntax, but quite pretty. Actually, let's do a left alignment here, just to keep things a little bit more tight to the left. And now let's say that we want to improve readability of these large numbers here by adding 1,000 separator. One way, according to the documentation, is to add a comma after the width. So that is going to add the comma as the 1000 separator. Another option is to have an underline, and that's going to have an underline as a 1000 separator. That's nice, but depending on the country of our customers, the standard 1000 separator character might be different. So how do we deal with this? What we can do instead is to use the n type specifier. Let's try it out. So instead of using this, we use a type instead, and the type is n. Nothing happened, but that is because my locale settings aren't really helping. Let's fix that by faking that we are somewhere else. So how do we do that? So up top here, I am gonna import locale, and I'm gonna say locale.set locale, locale.lc numeric, and let's set it to America, for example, ENUS. That's the code for American locale. So Python by itself, without my interference, already chose the correct 1000 separator for that country. So people in the US are going to look at these numbers and they're going to know that that comma means the 1000 separator. Let's pretend we are in Germany, for example. So to do that, we just need to type de.de for Deutschland. And now we see that they don't really use any 1000 separator. Okay, let's try Sweden instead. SVSE. Oh, in Sweden we have space as a 1000 separator. Let's try PTBR for Brazil, and there they use a dot as a 1000 separator. So we see that we can't really choose the 1000 separator on behalf of our customers because different cultures have different standards on what they really see in the numbers. An American seeing this dot here, they might think that this is a fractional number, whereas a Brazilian person might look at this number and really think it's 17,000. So this can avoid a lot of confusion. And the cool thing about that is that you don't need to worry about where your customer is in the world. Let their locale settings do the job of choosing the 1000 separator and everything else. How cool is that? And talking about the type specifier, there are many types available. And that is the next tip: easy base conversion. So let's start fresh here. Let's say that we have a number n, and say the number is 127,825. And now let's print. We know we're dealing with f string n, and let's see that that's printing correctly. Yes, that is printing our number back to us. And now we can start exploring the different options that we have for converting the base of this number. So looking at the documentation, for integers, we have these types available: B for binary, X for hexadecimal, O for octal, and kind of weirdly, we have this C to print out our Unicode character that corresponds to that point. There are better ways to do that in Python, a little bit more Pythonic. I don't know why they did it, but no, it's there. Let's try these options out now. Let's type our colon to tell Python that everything that comes after the colon is the format specifier, remember. Now let's skip everything and go straight to the last option, that is the type, and let's put a B for type. And that's telling Python that, hey, print this in binary format for me. And there you go, Python does its job, and this is the binary representation of the number 127,825. The hexadecimal representation, as easy as replace that by an X. And the octal representation is this strange number. And last but not least, if we print the Unicode character that is represented by this huge number, we get this emoji. The peach emoji code point is really 127,825. And the next tip is to improve the readability of these things. Use hash and underline for base conversions. So from the documentation, we have that this hash means alternate representation, and the underline is the separator that we've talked about before. So all that we have to do, let's go back to our binary representation. So we have those binary numbers, and before the B, we add the hash for binary representation, and we have this 0B added before the number, And that greatly improves readability. That tells everyone reading this number that this is a binary number and not the number 1,111,000. That makes it clear what kind of base we're talking about. And to really knock this out of the park, in between the two, we use the separator. Let's use the underline separator. And now Python is grouping those in groups of 4. And that makes the number 1,000 times more readable. Now we see that, oh, here's my first byte. Oh, here's my second byte. So my recommendation here really is use the hash and underline for the separator for when you're doing base conversions, because it makes things much, much easier to read. That's all you need. And that's really simple. And at the same time is elegant and sophisticated. And someone important sometimes said that the ultimate sophistication is simplicity. And this is what we're getting to here. And do you know what is even more sophisticated than that? It's to know what's going on under the hood. So you have the full power at your hand to alter and shape things as you want. So let's take a look at that. The next tip is know what's under the hood. I have saved the best for last, so congratulations if you made this far. Formatting like that is so easy that it makes it seem like magic, but the machinery behind is quite simple. So let's check it out. Okay, so for example, we have an F string and we have an object D being inserted into that string with a certain format specification. Whatever those values are for now, we're going to get into that. This is equivalent to calling the format built-in function, passing in the D object and the format spec as arguments. And this, according to the documentation, will result in a call to the dunder format method on the type of that object, with the object itself and the format spec as arguments. This is in the documentation, and this would make you believe that this format method should be a static method because you're passing the object itself here. But this is not quite true, and I don't really know why the documentation says things like that. But what this hints to us is that it's really simple to create objects that have our own format specification. So, well, let's do that. Let's create our object with our own format specification. So first of all, we need to create a class. I'm very uncreative by now, so I'm going to call this class hello. And we're going to construct it with an init method, which always receives self. And let's say that it receives a message. Very, very creative right now. And then we give this property called message, which is the message that is passed in. And now to make this work with the format built in, we need to define a format dunder method here. And this, we're not going to define this as a static method. We're going to define this as a normal method that simply receives the format specification here. And then we can do something with this object. So let's create some format specification for our object. So let's do something simple. Let's say that if we pass in the letter U as a format specification, we convert things to uppercase. And if we pass in the letter L, we convert things to lowercase. Let's try it out. So if format spec equals to U, we return self.message.upper. Otherwise, if the format spec equals to L, then we return self.message.lower. Yes, last but not least, if we don't recognize the format spec, we don't do anything special, self.message without any transformations. So there it is. This is our class. So now let's use the class and let's use our format specification. So let's instantiate it. So hello type with a message hello there. We're seeing here that my creativity is through the roof. And now all that we have to do is to print the object inside an F string, and we're gonna interpolate that object here. and we're going to put a colon for our format specifier, and we're going to give here either the letter U or the letter L. We're going to see if the message gets converted to uppercase, and there you go. It gets converted to uppercase, and we've passed the L here. Everything goes in lowercase. The first H here is in lowercase. And now we have our own formatting for our object that we can quickly select using the format specifier after the colon here. How cool is that? And with that cherry on the cake, we conclude this video, and hopefully you have taken your Python f-string knowledge to the next level. This is my first real YouTube video ever, so leave some love in the comments, like, subscribe, and let me know what you thought about the video and all those things that YouTubers are supposed to say in the end of their videos. But right now, my focus is not to grow this channel, but to learn how to make high quality content. So if you have constructive feedback, I would really appreciate that. And that's it for me today, and see you in the next video.